is supposed to be a friendly section. It's a section on something called a determinant. And a determinant is a number that's associated with a matrix. And it's a number that's only associated with square matrices. A square matrix has the same number of rows as columns. Like this matrix is a 2 by 3 matrix. It has 2 rows and 3 columns. We did a lot of those in the last section. This matrix wouldn't have a determinant or a number associated with it that we call a determinant. In order to be a candidate to have a determinant, you have to have the same number of rows as columns. Nicely, my calculator can do determinants, and they're not that bad to do by hand. So for the first 8 problems in this section, I give you matrices, ask you to find the determinant. I'll show you how to do them both on your calculator and by hand. When we get to the test, I won't be so picky. If you just do these via your calculator, it's fine. You'll find that some of them are probably quicker to do by hand. So to do a determinant on my calculator, the first I need to do is enter the matrix. So I'm going to go to the second in matrix again and get the 1A and matrix, let me do the second matrix. I'm going to get the 1A highlighted and edit highlighted just so I can enter the matrix. This is not any different than what we did in the last section. And when I do that and hit enter, I could actually make it so it shows up. And when I hit enter on that, this is a 2 by 2 matrix, so I'm going to type in 2 rows, enter, 2 columns, enter, and just enter the numbers as I see them. I see -2 and 4 in the top row, 3 and 1 in the bottom row. So I physically just entered that matrix onto my calculator, called it matrix A. And now that I have the matrix in, I'm going to second and quit. And then to find this number that's called the determinant, I'm going to hit the second in matrix key another time. And this time get the math up top highlighted and the option 1 that says DET highlighted. DET meaning determinant. So that's what I have going on here. I have the math in the middle column, the DET, and the math on the top, the DET highlighted. I'm going to hit enter. And then next to the DET, I need to get the name of the matrix, which is A. So I'm going to do second in matrix a third time. And I'm going to have simultaneously the 1A blackened out and the names, which I already have. And I hit enter twice. And the determinant of this matrix, the determinant of that matrix that I called A, is -14. If you see a matrix symbol, a matrix with the bars perfectly vertical, that means find the determinant. So I can say the determinant of this is -14. I'll do one more on my calculator, then I'll show you how to do them by hand. They're probably easier to do by hand than on your calculator. So I'm going to do number 4. To do number 4, I'm going to follow these steps. First thing, I'm going to enter this in my calculator. I'm going to go second matrix, simultaneously get the edit and A highlighted, hit enter. So still another 2 by 2 matrix. Type in the numbers -4, 5, -1, and 0. I have the matrix in, so I'm done with that. Second matrix, hit the A and the edit. Now I'm going to second and quit. Then I'm going to second in matrix again. Second in matrix again. Get simultaneously the math and the DET highlighted. The math is highlighted there, DET is highlighted there. Hit enter. And then second in matrix a third time, have the names and the 1 highlighted. Hit enter and enter again. And the determinant of this matrix is 5. So I'll do this for my answer. I'll say the determinant, and rather than saying the determinant in words, I'm going to use a symbol that means the determinant is 5. I could have written the determinant of the matrix, or the determinant, is 5. But this to me says the determinant is 5. Similarly, that says the determinant is negative 14. If I didn't have a calculator handy and I wanted to compute the determinant of problem 2 and problem 4, I would do 2 multiplications. I'd multiply down, cross multiply in some sense, multiply negative 2 times 1, that gives me negative 2. Then I'd cross multiply up, 3 times 4, that gives me 12. And I'm going to subtract those two amounts. So I'm going to go negative 2 minus 12. And do that on my calculator. Negative 2 minus 12 is negative 14. Not that you could see that, but it's frustrating as heck that you can't ever see that. So negative 2 minus 12 is negative 14. So I could compute that particular determinant probably quicker than you could enter it and compute the determinant. Similarly, if I wanted to do the determinant of number 4, I'm going to multiply down and go negative 4 times 0, which is 0, and multiply up, which is negative 1 times 5, which is negative 5, and subtract those two amounts. So I'm going to go 0 minus a negative 5. So the determinant is going to be 0, the first going down, minus the product going up, minus a negative 5. That double negative leads me to a plus, and that's why my calculator gives the determinant of 5. This is the easy kind of determinant that is hardly worth using my calculator to compute, because I could do this 2 multiplications and subtractions pretty quickly and pretty accurately. As matrices get bigger, finding the determinant by hand gets more complicated. The next 2 problems, problem 6 and problem 8, finding the determinant by hand is a little bit tedious, but finding it by my calculator isn't any different than it was for the last problem. So I'm going to do this determinant via my calculator by first entering it. So I'm going to go second matrix, simultaneously get the edit and the A highlighted, hit enter. This matrix has 3 rows and 3 columns, so I type in 3 by 3, and then I type all the numbers to make a matrix look just like the matrix that was given in problem 6. So I have, best you can see, I have 1, 0, negative 1 in the top row, 7, 2, 4, and 2, 3, negative 5. I hit second and quit. Then I go second in matrix, get the math and the DET both highlighted and hit enter. And then second in matrix, get the names and the A highlighted. And the determinant of this matrix is negative 39. So the determinant, I'll just say this, the determinant is negative 39. This is going to be tedious to do by hand. To do by hand, there's a couple ways to do it. The way that I'm going to do it is the way that I prefer doing it, but if you did this in high school, you might have learned a different way. What I'm going to do is take the initial matrix, write it down how it looks, and add the first two columns. The first column, 172, I'm going to add it, put it on another copy of it, and another copy of the 0, 2, 3 column. So I took the initial matrix and copied the first and the second column over, and now I'm going to do something similar to what I did in the first problems. I'm going to multiply those 3 numbers, 1 times 2 times negative 5. That's going to give me negative 10. And then I'm going to go 0 times 4 times 2, which is 0, and negative 1 times 7 times 3, which is negative 21. I'm going to add these 3 numbers. So I'm going to go negative 10 plus 0 plus negative 21. That's going to give me negative 31. So I'm going to just put that off to the side. That's going to be an important number. That's the number I got going down. It's not negative 39. It's not the answer. I'm not there yet. Now I'm going to do the same thing but go up. Start in the bottom left-hand corner as opposed to the top left, and go up and multiply. I multiply 2 times negative 1, which gives me negative 4. 3 times 4 times 1 gives me 12. And negative 5 times 7 times 0 gives me 0. I'm going to add those numbers. I'm going to go negative 4 plus 12 plus 0. That adds up to be positive 8. The determinant of this matrix, I subtract these two numbers. So to get this negative 39, I take the first number that I computed, which is negative 31, subtract the second number that I computed, which is 8. Negative 31 minus 8 is negative 39. Don't need to do any determinants by hand if you don't care to for this section. Eventually we're going to use the determinant to solve systems of equations, and it makes no difference to me if you just learn how to press buttons. They're not that important, and I was debating on not covering this section at all, although I'm technically required to cover it. The only time you're going to see this again is if you take linear algebra, which is Math 342, which means you're at ASU, which would mean you're an engineering major or a math major, and probably most of you aren't that, and most of you won't you won't see determinants ever. I'll do the same thing for 8. I'll find the determinant and do my calculator, then show you how to do it by hand. So on my calculator, I'm going to enter this matrix. Second matrix, over to edit. This is a 3 by 3 matrix. Enter 3, 2, 0, 4, negative 1, 3, 1, negative 5, 6. Make sure I get it entered reasonably correct. If anything is wrong, I'll get the wrong answer. Do second quit, and then second matrix math. Get the 1 in the DET highlighted, and then second matrix, have the names in the A highlighted, hit enter, and the determinant of this matrix is negative 15. I'll do it by hand. The way I'm doing it by hand is not the only way to do it by hand, it's just the way that I prefer. There's something called cofactors that you can use to expand this matrix to find the determinant. So I wrote down the matrix. I'm going to write down the first two columns. So for the small matrices, the 2 by 2 matrices, I didn't need to add anything to them. They were good the way they're written. For the big matrices, 3 by 3 matrices, I added the first two columns. Now I'm going to start multiplying down. 3 times negative 1 times 6 is negative 18. 2 times 3 times 1 is 6. And 0 times 4 times negative 5 is 0. I'm going to add those numbers. I go negative 18 plus 6 plus 0. When I add those, I get negative 12. Now I'm going to go from the bottom to up. I'm going to go 1 times negative 1 times 0, which is 0. And then negative 5 times 3 times 3, which is negative 45. And 6 times 4 times 2, which is 48. So I'm going to go 0 plus negative 45 plus 48. That comes out to be a positive 3. The two numbers that I'm adding have opposite signs. I subtract and take the sign of the larger. That gives me a positive 3. For the determinant, I subtract these two numbers. The first number that I computed was negative 12. The second number I computed was 3. And negative 12 minus 3 is negative 15. So that's how we would do a determinant by hand, a 3 by 3. So 2 by 2s and 3 by 3s, you can kind of do the determinants by cross multiplying. Once we get to a bigger size, a 4 by 4 or 5 by 5 or a 6 by 6, they're really messy to do the determinants, and I would just rely on the technology to do the determinant if I was really interested in finding the determinant. The reason determinants are interesting is that they give us a tool to solve a system of equations. So in the first section, we learned how to solve problems like this using the elimination method. In the second section, we learned how to solve 8.2. We learned how to solve systems of equations like this, doing matrices and kind of RREF on our calculator. In this section, we're going to learn how to solve this using something called Cramer's rule. But before I solve any problem, I like to know what the answer is. And I can quickly get the answer on my calculator using the RREF feature. So I'm going to rely on remembering section 8.2, because ultimately the easiest way to solve a system of equations in this style is using RREF on my calculator. It's not what's asked for in problem 10, but it's the answer that I get if I use the elimination method, if I use matrix row reduction, or if I use determinants. The answer is always going to be the same. So I'm going to get an answer to this real quickly because I know how to do this quickly. I'm going to go second matrix, edit, pretend like the problem's from the last section. I'm going to enter a 2 by 3 matrix. And that 2 by 3 matrix, I'm going to pull off the coefficient of 8, enter, -3, enter, and -2. And I didn't do 2 by 3. I need to go 2 by 3 matrix. Top row has an 8, a -3, and a -2. A bottom row has a 2, a 1, and a -4. Second quit. Second matrix math. Find the RREF. And then second matrix, enter, enter. The answer is supposed to be x equal -1, y equal -2. So I know the answer ahead of time, so I know whether I'm doing something right or wrong. The strategy that I just used to solve the problem has nothing to do with the way this problem is supposed to be solved, other than it has the same answer. To solve the problem using Cramer's rule, I have to create, in this instance, 3 determinants. The first determinant I call D. The second determinant I call D sub x. And the third determinant I call D sub y. A determinant's a number associated with a matrix. And each of the determinants that I set up and compute for this problem are going to have 2 rows and 2 columns. So I'm setting up to solve the problem using something called Cramer's rule, which back in the day was really slick. Pre-technology, doing matrices, the reductions by hand is a nuisance. Doing determinants by hand isn't that hard. So getting the answer without having technology, back in the day, this was preferred. When I was in high school, I'd do Cramer's rule all day before doing what we had to do in section 8.2. So I need to set up the determinants. And I set up the determinants by looking at my initial columns. I have 3 columns. I have an x column that has the numbers 8 and 2 in front of the x's. I have a y column which has the numbers -3 and 1 in front of the y's. And I have an equals column which has the numbers -2 and -4. The D determinant, it's going to have first the x column and then the y column. The x column are the numbers 8 and 2. The y column are the numbers -3 and 1. Eventually I'll figure out what that determinant is. But before I do, I'm going to set up the other 2 determinants. The next determinant, D sub x, the first column it has is the equals column. The second column it has is the y column. I'm changing the x to the equals column is essentially what I'm doing. And that tells me the column that needs to change. The x needs to change to the equals column. So the equals column is -2, -4. The y column is -3, +1. Eventually I'll get a number that equals that determinant. The last determinant I need to compute is D sub y, and that determinant takes the y column and changes it to the equals column. So I'm going to take, in the x column, I'm going to write the coefficients from the x column, which are 8 and 2. From the y column, I'm going to write the coefficients of the equal column, which are -2 and -4. So it's important so that you can see how these determinants are set up. The D has the x's, and the coefficients of the y's. The x's has the coefficient from the equal column and the coefficient from the y's. The d sub y has the coefficient from the x's, then the coefficients from the equals. I'm going to do each one of these determinants. I'll be super lazy and use my calculator. I can do them quicker by hand, but calculator sometimes is easier. So I'm going to go second matrix, edit. To do D, I type in a 2 by 2 matrix, type in 8, negative 3, 2, and 1. So the matrix is in. Hit second quit. Then I go second matrix math. Get the 1 and the DET highlighted. Then second matrix names in A. And the answer to what the D, that determinant is equal to 14. Now I'm going to compute the d sub x and get a number that associates with that. To do d sub x, I'm going to enter this matrix on my calculator. I'm going to go second matrix, edit, enter, enter, and then go negative 2, enter, negative 3, enter, negative 4, enter, 1, enter. So I've entered that matrix the best I can. Second quit. Slickly, because the last thing I have up here was DETA, if I hit second and enter, it'll pull that DETA back. So I hit second and enter then enter again tells me that this is negative 14. The last number I'm going to compute is the d sub y. When I do the d sub y, I'm going to enter that matrix. I'm going to go second matrix, edit, enter, enter, 8, enter, negative 2, enter, 2, enter, negative 4, enter. So I have that matrix in properly. Second quit. Since I have the line that I want, second and then enter again. And this is negative 28. I'm done with all the matrix work. Now I'm going to get my answers, and I get my answers by dividing. To get the answer for x, I take the determinant that I call d sub x, divide it by the determinant that I call d. You can kind of see that these d's are going to cancel, and you're going to be left with the x's. The d sub x number is negative 14. The d number is 14. If you divide that number, you'll get a negative 1. If you look at my answer, that's the negative 1 in my answer. To get the y portion of my answer, I take the d sub y number, divide it by the d number. Again, you can see how the d's are going to cancel. You're going to be left with the y. The d sub y number is negative 28. The d number is 14. When you divide that, positive divided by negative gives me a negative, and 28 divided by 14 would be 2, so that's going to be negative 2. So using Cramer's rule, which is using determinants to solve a system of equations, produces the same answer as using the RREF on my calculator. So for every problem I do in this section, first I'm going to do the RREF to know what the answer is. Then I'm going to use Cramer's rule. If my Cramer's rule answer doesn't match up with my RREF answer, then I've made a mistake somewhere, probably in the Cramer's rule, and I'll try to find that mistake. And if I didn't do a mistake in my Cramer's rule, that means I made a calculator error, and I'll redo my calculator work. So again, problem 12, if I was just asked to solve this and not given any instructions, the easiest thing for me to do is enter a matrix, a 2 by 3 matrix on my calculator, and do RREFA, and that's what I'm going to wind up doing to start. And that's going to give me my answer, what I'm shooting for. Once I have my answer, then I'll do the matrix work, the determinant work, to get the answer. So I'm going to enter a matrix on my calculator. The top row is going to be 5, 2, 1. The bottom row, 1, negative 7, 10. I don't know why that decimal point is there, but it's not necessary. I go second matrix, edit, and I type in 5, 2, 1, 1, negative 7, 10. Oh, I messed up. I made it 2 by 2. It's supposed to be 2 by 3. Go 5, 2, 1, 1, negative 7, 10. So I have the matrix. Not that you can really see this, but I just can't really find an awesome spot that works for every time. So there's the matrix. Second quit. Second matrix, math, RREF. Again, this has nothing to do with how the problem is supposed to be solved, other than the answer that I get is going to be the same. Oh, this is a fraction one. Math, enter, enter. The answer is going to be x equals 27 over 37. y equals negative 49 over 37. So that's the answer. Now I'm going to get the answer doing the proper way. If this was a test question and this is what you didn't show any determinant work, you wouldn't get any partial credit. You're going to get points for giving me the d sub x, and the d sub y. So to do this, I have to know what the x column is. The x column are the numbers in front of the x's, which are the numbers 5 and 1. The y column are the numbers in front of the y, which are 2 and negative 7. The equals column has the numbers 1 and 10. I'm going to create 3 determinants. The determinant d, the determinant I call d sub x, the determinant I call d sub y. They're the same for all 2 by 2 problems here. The d, the first column is going to be the x column of numbers. The second column is going to be the y column of numbers. So the d is going to have the numbers 5, 1, 2, and negative 7. The d sub x has the equal column of numbers and then the y column numbers. The equal column of numbers are 1 and 10. The y column of numbers are 2 and negative 7. The d sub y has the x column of numbers and the equals column. The x column is 5 and 1. The equals column is 1 and 10. I need to compute these 3 determinants. I can do them by hand or I can use my calculator. I'm preferring my calculator right now. I'm not feeling really intelligent, so I'm going to do this matrix, each determinant. They're all 2 by 2 matrices. So I'm going to enter the 2 by 2 matrix here. I'm going to go 5, 2, 1, negative 7. Have the matrix in best I can. Then second quit, second matrix math, DET, second matrix names, so I get DETA. When I do DETA, I get the number negative 37. That's one of the 3 determinants I need to compute. The next determinant I'm going to compute is d sub x. I'm going to go second matrix, edit. It's a 2 by 2 matrix. Type the numbers 1, 2, 10, and negative 7. Second quit. Because I just did a determinant, I could just hit second and then enter again, and this determinant is going to be negative 27. And the third determinant I need to find is from that 5, 1, 1, 10. So I'm going to enter that matrix, second matrix, edit. It's a 2 by 2 matrix. I type 5, 1, 1, and 10. Second and quit. Second and enter again, and I get 49. So I've set up my 3 determinants. I already know what my answer is, and I calculated the determinants. Now I'm going to get my answer. My answer for x is going to be the d sub x determinant divided by the d determinant. The d sub x determinant is negative 27. The d determinant is negative 37. That fraction doesn't really reduce, but when you divide 2 negatives, you can get a positive. So that gives me 27 over 37 for x. That's exactly what I had when I did RREF. To get the y, I'm going to take the d sub y number, divide it by the d number. The d sub y number is 49. The d number is negative 37. That fraction doesn't reduce. I could leave it like that and write that in the answer, but it looks odd to see a fraction with just a single negative number in the denominator. And you can move that negative and make it a coefficient, or you can write it in front in the numerator. But as long as you had a 49 and a 37 as a fraction with a negative somewheres in the numerator or the denominator or to the left of the fraction, that would be okay. So every single problem in this section, I'm going to do 2 things. I'm going to get the answer ahead of time doing RREF, and then I'm going to create determinants to solve the problem using this determinant method that's called Cramer's rule. And back in the day, this was cool because determinants aren't that hard to do by hand. In fact, I'm going to do the next few determinants by hand because they're just not that hard to do. First, I'm going to get an answer to this. I'm going to do a matrix, second matrix, edit. Now I have to enter a 2 by 3 matrix. Go 4, 1, 11, 3, negative 5, 37. Make sure I have that matrix in right. looks right enough to me. Hopefully you can see it decently. Second quit, second matrix math, find RREF, enter, second matrix, enter, enter. So the answer to this is going to be x equal to 4, y equal to -5. So there's no reason that I should get a wrong answer to any Cramer's rule problem because I know what the answer is ahead of time before I've even done a lick of algebra. I have the answer at my fingertips with a minute to get it. So I have to understand what the columns are here. The x column has the numbers 4 and 3. The y column has the numbers 1 and -5. The equals column has the numbers 11 and 37. Big numbers. The D determinant, you pull off the x column and the y column. The x column being 4 and 3. The y column being 1 and -5. The D sub x determinant, I write the equals column, then the y's column. The equal column being 11 and 37, the y column being 1 and -5. The D sub y, I write the x column, and then the equal column. The x column being 4 and 3, the equal column being 11 and 37. I lied. I'm going to use my calculator because I don't want to deal with multiplying by 11 and 37. Sorry. So let me do this. Second matrix, edit this 2 by 2, type the numbers 4, 1, 3, and -5 for the D. Then second quit, second matrix math and determinant, second matrix enter, enter. The first number comes out to be -23. Now I'm going to do this next determinant. So I'm going to go second matrix edit and enter 11, 1, 37, and -5. Second quit. Since I just did determinant, I could hit second enter to do the determinant again. This determinant is -92. And then the last determinant, I'm going to go 4, 3, 11, 37. So second matrix edit, enter, enter. 4, enter, 11, enter, 3, enter, 37, enter, second quit, second enter, enter, and this is 115. So on the test, you don't have to do a single determinant by hand. They're really not that hard to do by hand, but I didn't care to deal with the big numbers in the second ones. So now I'm going to do x. X is equal to d sub x over d. D sub x is -92. D is -23. I'm going to divide -92, so I'm going to go -92 divided by -23, and I get 4. Good thing, because that's supposed to be the answer for x. Do the same thing now for my y. Y is equal to d sub y over d. D sub y is 115. D is -23. So on my calculator, I'm going to go 115 divided by -23. My calculator tells me this is -5, which is beautiful because that's what the y is supposed to be. So Cramer's rule is not really horrible in terms of I'm not doing much in the way of hard algebra. I'm just doing divisions and determinants. Determinants I could do on my calculator if I'm not sure how to do them by hand. I like to do one by hand here. And I think the numbers in the next one, they're small enough that I can do these by hand comfortably. And then 18, the numbers are too big for me to want to do by hand. So let me do one by hand here, but get the answer ahead of time. So for 16, I'm going to get the answer ahead of time. Second matrix, edit. This is going to be a 2 by 3 matrix. I'm going to type in 4, enter, -3, enter, 10, enter, 2, enter, 1, enter, 10, enter. So I've entered the matrix the best I can. Second quit, second matrix, math, find my RREF, second matrix, names, enter. So the answer to this is supposed to be x equal to 4, y equal to 2. You don't ever have to do the RREF in this section. It does take extra time to do, but the nice thing about taking the time at the beginning to do the RREF, it gives you the answer. So now I'm going to set up, my columns are The X column has the numbers 4 and 2. The Y column has the numbers -3 and 1. The equals column has the numbers 10 and 10. The D determinant always has first the X column, then the Y column, until we get with some Z's. And that's going to be 4, 2, -3, 1. The D sub X column is going to be the equals column 10, 10, and then the Y column -3, 1. The D sub Y column is always going to have the X column and then the equals column. The X column is 4, 2, the equals column is 10, 10. If I wanted to do these determinants by hand, it's just not that hard. I'd multiply this down, 4 times 1, and get 4. Multiply this up, 2 times -3, and get -6. And I'd subtract those numbers. So I'm going to go 4 minus a -6. That double negative goes positive. The D is going to equal to 10. Could do that on my calculator if I didn't believe my algebra. On my calculator, second matrix, edit this, type in a 2 by 2 matrix, do 4, -3, 2, and 1, get the matrix in, then second quit, second matrix, math, DET, second matrix, enter, enter. That's the 10 that I got by hand. The next determinant, if I want to do it by hand, I'd go down, which is 10 times 1, which is 10, up, 10 times -3 is -30. I'd go 10 minus a -30. That double negative would make a plus. This determinant is going to equal 40. And I won't do that on my calculator. The last one, I'd go 4 times 10 is 40. 2 times 10 is 20. And then I go 40 minus 20 and get 20. So either with my calculator or by hand, the determinants aren't horrible to come up with until they have three, the Z part. So now I'm going to get the X. The X is going to be my D sub X number, which is 40, divided by my D number, which is 10. And 40 over 10 is just 4. Again, if you look at this 4 and that 4, they're the same. The Y is going to be my D sub Y number over my D. My D sub Y number is 20. My D number is 10. And 20 divided by 10 is 2. I see X equal to 4, Y equal to 2. Here I see X equal to 4, Y equal to 2. So I did it perfectly, even without resorting to my calculator to do all the determinants. But I don't care if you do every determinant via your calculator. I have no problems with that at all. There's so many of these. Okay, well, keep going. So hopefully you're almost getting tired and you're fast forwarding through this part. Get the answer for 18, second matrix, edit, do a 2 by 3 matrix in RREF, do 6, 2, 26, 2, -7, 24, and then second quit, second matrix, math, RREF, second matrix, enter, enter. The answer to this is supposed to be X equal to 5, Y equal to -2. To do this, I need to know my X column. My X column has the numbers 6 and 2. I need to know my Y column. It has the numbers 2 and 7. My equals column has the numbers 26 and 24. I need the D determinant, which is going to have the X column of numbers and the Y column of numbers, which is 6, 2, 2, and 7. I need the D sub X determinant, which has the equal column and then the Y column. The equal column is 26 and 24. The Y column is 2 and 7. Then I need the D sub Y determinant, which has the X column of numbers and the equal column of numbers, which is 6 and 2, 26 and 24. I'll do them all on my calculator. First one, second matrix, edit. It's a 2 by 2. And then after I start typing it in, I'm going to type in 6, enter 2, enter 2, enter 7, enter. And then second quit. And then second matrix math, determinant, second matrix names, A. This first determinant comes out to 38. I'll do the second one now. Second matrix, edit, at 2 by 2, 26, 2, 24, 7. Oops. Second quit. Second enter, enter. This is 134. And then the third determinant, second matrix, edit, another 2 by 2, then 6, 26, 2, and 24. Second and quit, second enter, enter. That's 92. So the x is going to equal the d sub x number over the d number, which is 134 over 38. And if I do 134 divided by 38, I've made a mistake. Tried to do it too fast. I don't know where my mistake is. 42, that one's okay. I'm going to redo the d sub x. Second matrix, edit, 2 by 2, 26, 2, 24, and 7. Second quit. Second matrix, math, det, second matrix, enter, enter, is 134. Really? 6. Oh, I see. My mistake is a really horrible mistake. All my determinants are wrong. Hopefully you caught my mistake. When I wrote the y column, that is supposed to be a -7. I didn't pull the negative sign, which makes my d wrong and my d sub x wrong. My d sub y is probably right because doesn't involve that mistake. I'm going to recalculate my d sub recalculate my d sub x. So the nice thing is I knew I was supposed to get 5 and I was getting 3.5. So I knew I had a mistake. Then that gave me the luxury of going back to find the mistake. That's the best thing about this. Most of the problems in this chapter, you know what the answer is. So if you have a mistake, you can go. You know you have a mistake, and it's not hard to get the answer without any algebra, which is really a luxury that we don't normally have. So I'm redoing the d. The d is supposed to be -46. I'm going to redo the x too. Really? And the x is supposed to be negative. D sub x is supposed to be -230. So it's supposed to be the case that I'm supposed to go -230 divided by -46 to compute my x. I'm hoping to get 5 there. So I'm going to go -230 divided by -46, and there's the 5 that I was hoping to get. I knew that when I started getting that decimal, bad things were going on. The y is supposed to be the d sub y number of 92 divided by the d number of -46. So I'm going to go 92 divided by -46, 46, -46. So 92 divided by -46, and I get -2, which is exactly what I hoped. There's x equal to 5, y equal to -2. That's exactly what I've written down there. Just did it without writing the x and the y. Time to get into bigger ones. So I'm going to skip problem 20. You can do problem 20, and when you do problem 20, well, you can figure out the answer ahead of time and check yourself. But I think I'm kind of overkilling on these, and for the rarities, I'm going to skip my problem. Now I'm going to do 22, which is a mess by hand, but not so much of a mess by my calculator. I'm going to get the answer by doing RREFA, doing a 3 by 4 matrix. So I'm going to enter a matrix that's going to help me know what the answer is. It's not the determinant strategy, but just like I did in the problems that just had x's and y's, I'm going to get my answer ahead of time. This answer is going to have an x, a y, and a z written in that order. I'm going to enter a 3 by 4 matrix to start. So I'm going to go second matrix, edit, 3 enter, 4 enter, then type 3 enter, -2, 1, and 15. So that's the top row, 3, -2, 1, and 15. The middle row is -1 in front of the x, 1 in front of the y, 2 in front of the z, -10 for the equals column. And the bottom row is 1 in front of the x, -1 in front of the y, -4 in front of the z, and 14 in the equals column. So I think I've entered the matrix properly, but I'll check real quickly. Looks good. Second quit, second matrix math, RREF, second matrix names, enter. The answer to this is supposed to be x equal to 5, y equal to -1, z equal to -2. That's the answer I'm going to get. I have 4 columns here. I have an x column of numbers, which there's a 3, a -1, and a 1 as the coefficients of the x's. There's a y column of numbers, which are -2, 1, and -1 as the numbers in front of the y's. There's a z column, which is going to have the numbers 1, 2, and -4. And there's an equals column, which is going to have a 15, -10, and a 14. Now I'm going to set up 4 determinants. One determinant I'm going to call D. D is going to have the x column of numbers, then the y column of numbers, and then the z column of numbers. So it's going to have 3, -1, 1, -2, 1, -1, 1, 2, and -4. Let me find that determinant since I'm thinking about it. I'm going to go second matrix, edit. This now is a 3 by 3 matrix. And I type the numbers 3, enter, -2, enter, 1, enter, -1, enter, 1, enter, 2, enter, 1, enter, -1, enter, 4, enter. Then I do have the matrix in, second quit, second matrix math, determinant, second matrix names, enter. This first determinant comes out to be 6. I have 3 more determinants to do. The next determinant I'm going to call d sub x. And d sub x in the x column has the first column is equals, then it's the y column of numbers, then it's the z column of numbers. So the x replaces the x column with the equals column. So it's going to be the numbers 15, -10, and 14, which are my equals column. Then the y column, which is -2, 1, and -1. The z column, 1, 2, and -4. I'm going to go ahead and compute that determinant. So I'm going to enter this on my calculator. Second matrix, edit, enter, enter. 15, enter, -2, enter, 1, enter, -10, enter, 1, enter, 2, enter. 14, enter, -1, -4, enter. So I believe I've entered that perfectly. No, I haven't, because I did 3 by 15. It's supposed to be 3 by 3. That's not good, so recalibrate. So it's 15, -2, 1, -10, 1, 2, 14, -1, -4. Double check because these are bigger. Looks good. Second and quit. I just did determinant, so I'm going to hit second enter and enter again. And I have a mistake somewheres. And I'm not sure where, but I know I divide d sub x divided by d, and I'm supposed to get 5, and I'm not. Let me check these two real quickly. I'm going to go second matrix, edit, enter, enter. 15, -10, and 14 is my first column. Then my y column is -2, +1, and -1. My z column is 1, 2, and -4. That one looks okay. Second enter, second enter. So I think that's fine. Let me read you the D. Second matrix, edit, enter, enter, 3, enter, -2, enter, 1, enter, -1, enter, 1, enter, 2, enter, 1, enter, -1, enter, -4, enter. Looks reasonable to me. Second and quit. Second, enter, enter. Haha, that's better. So I entered something wrong on my calculator. So immediately I knew I had a mistake because it's still going to be the same. It's going to be the case that x is d sub x over d. And I was dividing in my head ahead of time. I was going -10 divided by 6. That wasn't going to give me the 5 that I needed to because x is supposed to be 5. Now it's going to be 5 because when I do -10 divided by -2, I get my 5. Let me do the d sub y determinant. The d sub y determinant has an x column, the y column replaced with the equal column, and then a z column. The x column is 3, -1, 1. The equals column is 15, -10, and 14. The Z column is 1, 2, and negative 4. Try to enter that properly. Second matrix, edit, enter, enter, 3, enter, 15, enter, 1, negative 10, 2, 1, 14, negative 4. After I get the matrix in, looks proper, best I can. Second quit, second enter, and enter. I get 2 for this. So this tells me that d sub y is 2. And I know, just like before, y is going to be d sub y over d. The d sub y number is 2. The d number is negative 2. 2 divided by negative 2 is negative 1. So that's good. Last thing I need is the last new step, d sub z. The d sub z matrix has the x column, the y column, and the z column changes to the equal column. So each one of these, the x column changes, the y column changes, and the z column changes to equal column. So I get the x column, 3, negative 1, and 1. The y column, negative 2, 1, negative 1. The equals column, 15, negative 10, and 14. I'm just going to enter that mindlessly. Second matrix, edit. It's another 3 by 3 matrix. 3, enter, negative 2, enter, 15, negative 1, 1, negative 10, 1, negative 1, 14. Make sure it looks right. Not that you can kind of see that. Second quit, second enter, enter. This gives me 4 for the d number, d sub z number. And I know that z is the d sub z number over d. The d sub z number is 4. The d number is negative 2. That's a positive divided by a negative, so I get a negative, and 4 divided by 2 is 2. So I see x equal to 5, y equal to negative 1, z equal to negative 2. Exactly what I knew before I started using Cramer's rule. So these problems are just longer, but they're not really different. When I go to do problems 24, 26, and 28, they're going to work exactly the same way. First of all, I'm going to get a solution. So for 24, I'm going to enter a 3 by 4 matrix, second matrix, edit, type in a 3 by 4 matrix, which is going to be 4, 4, 4, 12, 4, negative 2, negative 8, negative 12, 5, 3, 8, and 21. Then second quit, second matrix, math, go up to the RREF, second matrix, enter, enter. The answer to this is supposed to be x equal to 1, y equal to 0, z equal to 2. Write down my columns now. The x column of numbers are 4, 4, and 5. The y column of numbers is 4, negative 2, and 3. The z column of numbers is 4, negative 8, and 8. The equals columns are 12, negative 12, and 21. The D matrix has the x column of numbers, the y column of numbers, and the z column of numbers, which is 4, 4, 5, 4, negative 2, 3, 4, negative 8, 8. Find that determinant, enter a 3 by 3 matrix. So 4, 4, 4, 4, negative 2, negative 8, 5, 3, 8. So I've just entered that matrix. Then second quit, second matrix, math, determinant, second matrix, enter, enter. Whoa, negative 168. Slightly alarming, but I'll believe that it's not wrong until I confirmed that I've messed up. The d sub x has to have the equals column, which is 12, negative 12, 21. Then the y column, 4, negative 2, and 3. And then the z column, 4, negative 8, and 8. I'm going to enter that on my calculator. So second matrix, edit, 3 by 3, 12, 4, 4, negative 12, negative 2, negative 8, 21, 3, 8. Second quit, second enter, enter. I get negative 168. This is good because Now I know that the x is negative, forgot the negative sign here. The x is the d sub x number over the d number. The d sub x number is negative 168. The d number is negative 168. Anything divided by itself is 1, so the x equal to 1 comes out perfectly. Now I'm going to do the d sub y. The d sub y has the x column first, which is 4, 4, and 5. Then in place of the y it has the equal column, which is 12, negative 12, and 21. And then in the z column it has 4, negative 8, and 8. I'm going to enter those. Second matrix, edit, that's a 3 by 3 matrix, 4, 12, 4, 4, negative 12, negative 8, 5, 21, 8, second quit, second enter, enter. I get 0 for the d sub y, which is good, because y is d sub y over d, which is 0 over negative 168. Anything over 0 is 0. This negative really is not standing out there. And so this gives me the 0 for the y. The last thing I'm going to sneak in here is the d sub z. The d sub z has the x column, 4, 4, 5. The y column, 4, negative 2, 3. And then instead of the z, the equal column, 12, negative 12, 21. I'll find this determinant. Second matrix, edit, enter, enter, 4, enter 4, enter 12. 4, enter negative 2, negative 12, 5, 3, 21, second quit, second enter, enter. I get negative 336, and z is the d sub z number over my d, which is negative 336 over negative 168. And I'll do that in my calculator. Go negative 336 divided by negative 168. And my calculator tells me that that's 2, and that's exactly what I hoped. X equal to 1, y equal to 0, z equal to 2. That's what I'm supposed to get. That's what I got, so that's perfect. I'm going to do 2 more, but if you don't need to watch them, you can stop the video. But if you need to watch them, go ahead and watch them. They're not going to be any different. So 26 and 28 are going to work essentially identically. I'm going to get the answer ahead of time because I can, and I prefer having an answer at my fingertips so I can tell if I'm messing up. That's the best thing about this matrix section, is that I can know my answers ahead of time. I'm going to enter a 3 by 4 matrix and do the RREF so I know what the answer that I'm shooting for is. So I'm going to type in 1, 1, 2, 6, 2, 3, 1, 11, 5, 4, 2, 19, second quit, second matrix, math, RREF, second matrix, enter, enter, math, enter, enter, yuck. I see 17 over 11, 25 over 11, 12 over 11. I'm going to check that matrix to make sure that I actually entered it okay, because I might not have. 1, 1, 2, 6, 2, 3, 1, 11, 5, 4, 2, 9. I think I've entered it right. So now I need to know the x column of numbers, which are 1, 2, and 5. The y column of numbers, which are 1, 3, and 4. The z column of numbers, which are 2, 1, and 2. The equals column, 6, 11, and 19. Do my 4 determinants. First determinant, d, which has the x column of numbers, the y column of numbers, then the z column of numbers. So it has 1, 2, 5, 1, 3, 4, 2, 1, 2. Do that. Second matrix, edit, 3 by 3, 1, enter 2, 2, enter 3, enter 1, 5, enter 4, enter 2. Second quit, second matrix, math, determinant, second matrix, enter, enter. This is negative 11. Then I'm going to do the d sub x, which is going to have the equals column, 6, 11, and 19. Then the y column, 1, 3, and 4. Then the z column, 2, 1, and 2. Second matrix, edit, enter, enter, 6, enter 1, enter 2, enter 11, enter 3, enter 1, enter 19, 4, and 2. second quit, second enter, enter, I get negative 17. This is good because x is d sub x over d, which is negative 17 over negative 11. The two negatives cancel. I get 17 over 11, which is exactly what the x is supposed to be. The d sub y is going to have the x column, 1, 2, and 5. The equals column where the y was, 6, 11, and 19. And then the z column of 2, 1, and 2. So second matrix edit, enter, enter, 1, enter, 6, enter, 2, enter, 2, enter, 11, enter, 1, enter, 5, enter, 19, enter, 2, enter, second quit, second enter, enter. This gives me negative 25. And the y is going to be the d sub y number over the d number. The d sub y is negative 25. The d is negative 11. The two negatives cancel to become a positive. I get 25 over 11 for the y, which is what I thought it should be. And lastly, the d sub z is going to have the x column, 1, 2, 5. The y column, 1, 3, 4. The equals column, 6, 11, and 19. Second matrix, edit, enter, enter. 1, enter 1, enter 6, 2, enter 3, enter 11, 5, enter 4, enter 19, enter. That's 19. Second quit, second enter, enter. This gives me negative 12. And the z is going to be the d sub z number over the d number. The d sub z is negative 12. The d is negative 11. The two negatives cancel, and I get 12 over 11, which is exactly what I knew it should be. So I did that perfectly and fairly quickly because they're just all the same at some point. There isn't every single problem in this section other than the beginning problems are essentially the same. So last problem, 28. I'm going to get the answer doing RREFA. Again, that's all you did. You wouldn't get any credit because that's not the instructions. The instructions say to solve using Cramer's rule, which is the determinants. But I'm going to enter this matrix. And I'm going to go second matrix. I'm going to enter a 3 by 4 matrix. 1, negative 1, 1, and 2 for the top row. 2, 1, 1, and 5 for the middle row. 7, 4, negative 1, and 9 for the bottom row. And do RREFA. And I get 1, 1, and 2 for my answers. Now I know the x column of numbers are 1, 2, and 7. The y column of numbers are negative 1, 1, and 4. The z columns are 1, 1, and negative 1. The equals column is 2, 5, and 9. First thing I do is the d, which has the x column, 1, 2, and 7. The y column, negative 1, 1, and 4. The z column, 1, 1, and negative 1. I'm going to enter that and do the determinant. So second matrix edit, that's a 3 by 3. 1, go to 1, negative 1, negative 1, 1, 2, 1, 1, 7, 4, negative 1. Have that in properly. Second quit, second matrix math, determinant, second matrix names A, enter, D is equal to negative 13. Now I'm going to do D sub x. D sub x has the equals column, 2, 5, and 9. Then the y column, negative 1, 1, and 4. Then the z column, 1, 1, and negative 1. Second matrix edit, 3 by 3 still. 2, enter, negative 1, 1. 5, enter, 1, 1. 9, 4, negative 1. Second quit. Second enter, enter. I get negative 13 for the d sub x. And I know that x is d sub x over d, which is negative 13 over negative 13, which is 1, which I knew that to be the case. The d sub y determinant is going to have the x column, the equal column, and then the z column. The x column is 1, 2, 7. The equal column is 2, 5, 9. The z column is 1, 1, negative 1. So second matrix edit, 3 by 3. 1, 2, 1, 2, 5, 1, 7, 9, negative 1. Second quit. Second enter, enter. Gives me another negative 13, which which is still good because y is d sub y over d. D sub y is negative 13, d is negative 13, negative 13 over 13 is 1. I got that properly. The last one I need to do is d sub z. D sub z has the x column, the y column, the equal column. The x column is 1, 2, 7. The y column is negative 1, 1, 4. The equal column is 2, 5, and 9. Enter that. Second matrix, edit, enter, enter. 1, enter, negative 1, 2, 2, 1, 5, 7, 4, 9. Second quit, second enter, enter. I get negative 26. The z is going to be the d sub z number divided by d. The d sub z number is negative 26. The d number is negative 13. The two negatives cancel to be a positive. 26 divided by 13 is 2. So I have my x for 1, I have my y for 1, and I have my z for 2, which is exactly what I knew it should be. So this was supposed to be a friendly section. The next section is also supposed to be a friendly section. So we get back-to-back, moderately nice sections. And that lecture should be shorter than this one. There aren't near as many problems to do in that one.